Hi there! Today we're going to talk through Lesson 7-3 and solve multi-step equations. Our I can statement for this lesson is I can solve multi-step equations and pairs of equations using more than one approach. So what we're going to be looking at here is combining a lot of the strategies that we've been using, where we've had the distributive property, we've combined like terms, we have had variables on both sides of the equation, and we're going to combine all of these skills in order to solve multi-step equations in this lesson. So let's get started. Example 1. Use the distributive property to solve a multi-step equation. A math teacher recorded the distances he rode his bike last week. He challenged his class to find the number of miles he rode on Thursday. How far did he ride on Thursday? Take a look at the calendar that you see here, okay? And Thursday is represented by the variable x. The total number of miles he rode on Monday through Wednesday is the same as the total number of miles he rode on Thursday through Saturday. So we see that statement right here. So what that means is we can split this into two equations and set them equal to each other. So the amount of miles that he rode Monday, Tuesday, and Wednesday is represented by the expression 4x plus 3. However, the number of miles that he rode on Thursday through Saturday must be combined. So you see in the bar diagram here, to represent the situation, that our Monday through Wednesday miles are the top bar, and our Thursday through Friday miles are the bottom bar. And what we're going to do is we are going to call these equal expressions. So notice that 4x plus 3 must be equal to x plus 2 times x plus 7. Now you might be wondering why there's a 2 in front of the x plus 7, and that's in parentheses. And it's because that x plus 7 expression appears for both Friday and Saturday. So what we have is we have 2 of that expression. Now we're going to go ahead and solve the equation. You can see here that in their work, the first thing that they did is distribute the 2 on the outside of those parentheses to each term on the inside. So that 2 gets multiplied by the x and times the 7. And by doing that, you end up on the right side of the equal sign with x plus 2x plus 14. And you can still combine the x and the 2x terms together, and you get the 3x that you see there. Now you're going to solve this equation just like we did in the previous lessons where we had variables on both sides. So 4x plus 3 equals 3x plus 14. So now what we're going to do is they have elected to take away 3x from both sides. And that leaves us with 1x plus 3 on the left and 14 on the right. And then we're going to go ahead and subtract the 3 from both sides, and x must be 11. To check our answer, we would put 11 back into one of the original expressions, okay, or into both of those expressions, and check to make sure that both sides of that equal sign end up being the same. So what we know is that the teacher rode 11 miles on Thursday. Now I'd like for you to go ahead and try the try it question at the bottom of page 402 that goes with example 1. If you don't want to use the boxes, or if the boxes seem to be too confusing, that's okay. Just use the space on your paper outside of those boxes to go ahead and solve the equation that you see here, and we'll come back and talk about those in just a minute. So please pause the video while you do that, and then we'll come back and check your answer. All right, let's go ahead and take a look at the solution that goes with the try it. The first thing that we need to do is distribute this 3 to the x and to the 5 inside those parentheses. And by doing that, you end up with 3x plus negative 15 minus 5x equals negative 25 plus 6x. Then you need to simplify by combining some like terms that you see on the left side. So you have the 3x and the negative 5x, and that equals the negative 2x here, okay, plus the negative 15, or minus 15, equals negative 25 plus 6x. So the next thing that we're going to do, our next step here, is to go ahead and add 2x to each side. And by doing that, we get negative 15 equals negative 25 plus 8x. And that's the step that you see here continued in the second column. Negative 15 equals negative 25 plus 8x. The next step, looking now across over here, because I did the work that we normally do in a vertical fashion, and we add 25 to each side because the 8x now is all on the right side. So that means we're going to move our numbers all to the left. Okay, and doing that, we end up with 10 equals 8x. That's this piece right here. And then we have to divide both sides by the 8, and we get x equals 10/8. But you know that that's not simplified. So this might be our answer initially, but we still have to do some simplifying. So take that 10/8 and divide both parts of that by 2, and you get 5/4. Or if you change that back into its proper form as a mixed number, it would be 1 1/4. Now when you look at example 2, please don't forget that when you distribute the number on the outside of parentheses and it's negative, you do have to distribute that negative sign as well. So in part A here of example 2, you have to multiply each term on the inside of those parentheses by the negative 5. Okay. And then go ahead and solve that equation as you normally would. In part B, remember that that 3 is outside the parentheses, but it's not being multiplied. So this equation technically says 3 plus a negative 1 times x minus 3 equals 25. So what you're distributing here is a negative 1 to each of those terms on the inside of those parentheses, like you see here. And then you can go ahead and solve it as normal. Just don't forget that because the x ends up having a negative sign in front of it, that you do have to divide by that negative 1 in order to get the value of x, not negative x. Now when you do example 3, it's the same kind of thing. Sometimes you might have a situation where you have to use the distributive property on both sides of the equation. No more difficult, but just may require a couple of extra steps. Okay, so you can look through the example and the work that they've shown there. And then we're going to do the try it here together. So the first thing that I'm going to do is I'm going to take that negative 3 on the outside of the parentheses, and I'm going to multiply it times each term on the inside. Then I'm also going to multiply on the right side of the equal sign, the 1/2 that's on the outside of those parentheses, times each term inside the parentheses on the right side. And then my next step is to simplify. So here's what that looks like once we have those terms on each side of the equal sign simplified. Now we're going to go ahead and solve this just like we normally would by taking the same thing from both sides. Now you can either start with a variable term or you can start with a number term. In this case, I think I'll start with a variable term, and I'm going to take away the 1/2 x from each side. And since I write pretty large, that doesn't leave me a whole lot of space here. So on the left side of the equal sign, I still have the 21 plus, and then 3x take away 1/2 x is 2 1/2 x, and that equals 1 on the other side. Now I'm going to go ahead and take away the 21 from both sides, and a negative 2 1/2 x equals negative 20. Now in order to finish this, I need to divide both sides by a negative 2 1/2. Or I can change that into its improper fraction form, which is 5/2, negative 5/2 x equals negative 20. If I can get my stylus to work there. There we go. And then multiply both sides by a negative 2/5. and then see if you get what I get for x. In this case, x equals 8. The key concept at the top of the page reminds you of two strategies. One, when solving multi-step equations, sometimes you distribute first and then combine like terms. And sometimes you combine like terms first and then distribute. Okay? So either way you can do those problems, but sometimes you make it easier on yourself if you choose the most efficient manner of solving. If the like terms are inside parentheses, then combine them before you use the distributive property. All right, now I'd like for you to try questions 4, 5, 6, and 7. And go ahead and stop the video while you're working, and as you finish each one, you can restart the video to see that solution. Time to check your answer for number 4. You can go ahead and stop the video so that you can check your work. Notice that I did this kind of in two parts. The first part up here at the top, those first 2 lines, I did where I just used the distributive property and combined like terms. Then starting in the third step on is where I was doing my equation solving. Okay, I'd already combined my like terms and I was ready to go. All right, pause the video and we'll go on to number 5. All right, now go ahead and check your work on number 5. And again, if you have any questions about these, please come see me before you go on. And go ahead and check your answer on number 6. This one's a little bit longer, takes a little bit more space because of the fractions. Don't forget when you're adding or subtracting fractions, you have to have that common denominator. If you have any questions about how I got the fractions that I did or the values that I did there, please come see me before you move on. And finally, go ahead and check your answer to number 7 before moving on to the next page. Now I'd like for you to try questions 8 through 20 on the practice and problem solving pages. You can stop the video as you do each one. Okay, come back and check your answer for that particular problem, and then pause the video as you go on to the next problem. So when you finish, you should have all of your practice and problem solving questions answered. Please don't forget that showing your work is the most important part of this, because that's what tells you whether or not you're doing the problems correctly. There's number 8. Pause the video while you're checking, and then go on to number 9. And there's number 9. Pause the video while you're checking your work before you go on to number 10. And there's number 10. Again, check your work and pause the video while you do that before you go on to number 11. And there's number 11. Again, pause the video, check your work before you go on to number 12. And there you have number 12. All right, go ahead and take a look at the work that goes with number 13. Again, this one's a little bit longer because the fractions do require common denominators. In this case, the common denominator is a 6. So if you change everything over to 6, you'll be able to compute much easier. Again, if you have questions about what I've done here on any of this work, please come see me before you go on to the next problem. And go ahead and check number 14. When you've finished with that, go on to the next page. Let's do the same thing for questions 15 through 20 that we just did on the front side of this page. Go ahead and solve each problem and come back and check your answers as you go. Let's start with number 15. All right, go ahead and check number 15. Notice that above number 15 there, I rewrote the problem and took out all the subtraction, and I changed it to adding the opposite. And I did that intentionally so that you could see that when you distribute on the left side of that equal sign, you're actually distributing a -2 to each of those terms, which does change the signs. And then you can see below the problem there that I have done all of that solution work for number 15. So go ahead and pause the video while you check your work and your answer and make any necessary corrections. Again, as always, come see me if you have questions about number 15 before you move on to the next one. Now let's take a look at number 16. This one was pretty simple to solve, but the question does ask you to describe what it means to distribute the 2 to each term inside the parentheses. So don't forget that the 2 outside the parentheses means that you have 2 groups of the m plus 2, so that's why you multiply both of those terms by 2, and that's in order to get 2m plus 4. And there you have number 17. Again, go ahead and check the equation that I wrote first. Notice that it does tell us to multiply the difference of his number and 12 by -3, so that's why it's outside the parentheses, because we're supposed to find that difference first. And then you have to use your distributive property, like I did here, in order to solve for his number. Notice that on number 18, the first thing I did is I got a common denominator with all of the x terms. Now that I have a common denominator, I can easily combine like terms and solve this equation. And go ahead and check the rest of the work and the solution that goes with number 18. Here's number 19. And finally, the last one, number 20. All right, again, if you have any questions at all about your practice and problem solving work, come see me. Before you get started on your assignment, let's go through any of these that you had trouble with together so that you're better prepared to do your work independently.